All right, so you're here because you want to know what's happening on the cutting edge, right? The latest research, particularly where theory meets practice, particularly machine learning, yeah.
Exactly, and that's what we're diving into today, right? Explainable recommendation systems.
Huge area. Building trust with users, making AI decisions better, that's what it's all about.
Absolutely. We're going deep on this paper. It's called Counterfactual Language Reasoning for Explainable Recommendation Systems. It's a mouthful, I know. But the core idea here is, how do we make sure those explanations for recommendations, they're actually, the reason behind the recommendation.
Not just tacked on after the fact, right?
Exactly. The explanation should be the cause, and the recommendation should be the effect.
That makes sense. So the explanation comes first, then the recommendation follows, kind of a natural flow.
Right. And that's where causal models and LLMs, large language models, come in.
LLMs. Everybody's talking about LLMs these days.
It's exciting stuff. And this paper's using them in a really clever way. And another thing they're tackling is popularity bias.
Oh, yeah. That's a big one.
Huge. They want to make sure those explanations, they reflect genuine user preference, not just what's popular.
We all know those recommendations. Trending now, most popular. But is it actually something I'd be interested in?
That's the question.
So, all right, let's get into this.
Great.
The paper starts by pointing out a really basic problem with a lot of current systems.
Yeah.
They recommend something, then they try to explain it.
Like putting the cart before the horse.
Exactly. They're saying the logic is backward, the explanation should be driving the recommendation. That disconnect leads to explanations that might not reflect how the system made the decision in the first place.
Right. It's like, imagine your friend recommends a movie, right?
Okay.
And they say, hey, you should watch this, it's got a great plot. But really, they just recommended it because it's popular.
Uh-huh.
That explanation about the plot, it might not be the real reason.
It's just something they came up with after the fact.
Exactly.
Mm-hmm.
And existing recommendation systems, a lot of them work similarly.
They kind of backpedal into the explanation.
Yeah, some try to explain after the fact. These are called post hoc methods. Others generate recommendations and explanations simultaneously in parallel, but without a strong connection. This paper argues that in both cases, the explanations can be, well, a bit misleading.
They're not really grounded in the system's decision-making.
Right.
So this is where their framework comes in, right?
Exactly. It's called Causal X.
Causal X, catch name.
It makes sure the explanation comes first and then leads to the recommendation. And they use LLMs, those large language models, for both.
So LLMs are at the heart of the whole causal chain here.
That's right. They've got this three-part structure, really interesting. First part is this user item matching module.
User item matching, okay.
Yeah, it uses neural networks, those are standard techniques in ML, to figure out how compatible a user and an item are based on all their data.
Right, you've got data on the user, data on the item, try to see if there's a match there.
Right. And they use specific types of neural networks, generalized matrix factorization, GMF, and multilayer perceptrons, MLPs.
GMF, MLP, those are like the building blocks of a lot of these neural networks.
Exactly.
Yeah.
And that initial matching score, it feeds into the next part, the explanation selection module.
Okay. Explanation selection, this sounds like where the magic happens.
This is where they tackle that popularity bias head on.
Yeah.
Sometimes things are recommended just because they're popular, right?
Yeah.
Not because they truly match what you like. And this can also mess up the explanations.
Yeah, they might just echo that popularity. You might get an explanation like, people who bought this also bought that, which doesn't really tell you anything about why you might like it.
It's all about conformity, not genuine interest.
So how do they debias these explanations?
This is where it gets really interesting. They use this technique called counterfactual analysis.
Counterfactual analysis, okay.
So first, they use the LLM to generate a bunch of potential explanations for why a user might like an item.
Brainstorming with the LLM.
Exactly.
Yeah.
Then they group those explanations using this clustering method called HDBScan.
HDBScan, just another tool in the machine learning toolkit.
Right. This helps to reduce redundancy. Get rid of explanations that are basically saying the same thing. Now, here's the counterfactual part. They ask, what would the explanation be if this item wasn't popular?
Uh-huh. Like removing the popularity factor from the equation?
Exactly. It's like, okay, if everyone wasn't raving about this new phone, would you still want it based on its features, its design, its functionality?
It forces you to look beyond the hype.
Precisely. And they train the model to learn from both the real world, where popularity exists, and this imagined world, where it doesn't. This helps the model to score explanations based on real user interest, not just popularity.
So it learns to distinguish between genuine appeal and just following the crowd.
Right.
So you've got the initial matching score, you've got the de-biased explanations. What happens next?
Okay, so now we're at the final stage, the LLM-based recommendation module.
This is where we get the actual recommendations, right?
Exactly. They take those selected de-biased explanations, the user's profile, and the candidate items, feed it all into another LLM. And here's the key. They prompt the LLM to rank the items based on those explanations.
So the explanations are driving the recommendations directly.
That's right. The LLM is saying, okay, based on these reasons why you might like these things, here's how I would rank them for you.
That makes so much sense. It completes that causal loop.
Exactly. The recommendation follows logically from the explanation, which was the whole point of this research.
And they tested this framework, right? Real-world data. How did it perform?
Yeah, they tested it on 3 data sets. Booleans, Amazon CDs and vinyl, and Amazon books. Pretty standard data sets for recommendation systems research.
I've seen those used in other papers, yeah.
And the results were really good. Causal X outperformed other explainable recommendation systems, both in terms of accuracy and explanation quality.
Accuracy meaning, did it actually recommend things people would like?
Exactly. And explanation quality. They measured that using LLM-based metrics and even had humans evaluate the explanations.
So they covered all the bases, really put it through its paces.
Yeah, they did. And another interesting finding was that Causal X performed just as well as those recommendation systems that don't even try to provide explanations.
So they got the explainability without sacrificing accuracy.
Which is a big deal.
That's impressive.
It was also much better than just using LLMs directly for recommendations, without this whole causal framework.
So the framework really adds value. It's not just about the LLMs themselves.
Exactly. They also did those ablation studies.
Ablation studies, remind me what those are.
So they basically remove parts of the system to see how important they are. Like if you take out the popularity debiasing, performance drops.
Ah, so it shows that each component is actually doing something useful.
Exactly. Same thing when they used random explanations instead of the selected ones, results were much worse.
So having those relevant explanations really matters.
It really does. They also looked at how the system performed on popular versus less popular items, long tail items. Causal X did a good job of reducing that popularity bias, but without hurting its ability to recommend popular items that people genuinely liked.
That's a good balance to strike. You don't want to completely ignore popular items. They're popular for a reason.
Right. And not surprisingly, they found that using more powerful LLMs generally led to better results, especially when generating those initial explanations.
Bigger models, better performance. That's pretty common in machine learning these days.
It is.
So big takeaway here is that Causal X is a promising way to build these better explainable recommendation systems, right? By putting the explanation first and tackling that popularity bias.
Absolutely. It's all about making those explanations the real reasons behind the recommendations.
Now let's step back a bit. Explainable recommendations, this isn't a brand new idea, right?
No, it's been around for a while.
Sure.
Early systems used simple rules or templates to generate explanations.
Like, you might like this because you bought that.
Exactly. As machine learning evolved, we saw methods that could pick out specific features that led to a recommendation.
Like, we recommend this movie because you liked other action movies with this actor.
Right. But the explanations were still pretty basic. Then came LLMs, large language models.
Everybody's favorite.
They allowed for much more natural and human-like explanations.
Big step forward.
But this paper raises a really important question. Are those explanations truly reflective of the system's reasoning? Or are they just plausible stories?
It's like, are they explaining or are they just making excuses?
Exactly. And this paper tries to bridge that gap by enforcing that causal link, ensuring the explanation is the cause and the recommendation is the effect.
Makes sense. This also fits into this broader trend in AI, right?
Yeah.
Using causal reasoning to deal with issues like bias, understanding the underlying causes of things, not just correlation.
Right. It's not enough to just predict what you might like. We want to know why. And this paper is pushing us in that direction.
So the key idea here is that causal framework, right? Explanations first, recommendations follow, all while trying to mitigate the influence of popularity.
That's the gist of it.
And the potential benefits are huge.
Absolutely. We could see more trustworthy recommendations, which would make people more likely to actually use them. We might also see a reduction in those filter bubbles.
Filter bubbles, right? Where you only get recommended things that are similar to what you've already seen.
Exactly. And this system could help to break out of that, recommend more diverse and niche items, things you might not have even known you were interested in.
That's what I love about recommendations, the serendipity. discovering something new that I never would have found on my own.
Right. And this system could help with that.
Right. Now for the fun part, novel notions segment. What are some future directions this research could take?
Okay, so building on their work on the influence of explanations, I think there's potential for something like interactive causal exploration.
Interactive causal exploration. Okay, I like it already.
What if users could actually talk to the system about the explanations?
Like have a back and forth about why the system is recommending something.
Exactly. Imagine you get a recommendation with the explanation, this is popular. You could say, yeah, but I don't care about popularity. What makes it a good match for me?
You're challenging the system's reasoning.
Right. And the system could then try to find alternative explanations or even adjust its understanding of your preferences based on that feedback.
So it's learning from the user's input, refining its model in real time.
That's the idea. And it ties into this whole field of interactive AI, using human feedback to improve systems.
Really interesting.
This paper, it lays the groundwork by showing that causal link between explanations and recommendations. User feedback on the explanations, that could act as a new form of causal intervention, really guiding the system towards better understanding what the user wants.
You're not just passively receiving recommendations anymore, you're actively shaping the system's understanding of you.
Right. Think about the impact. Recommendations that are based on your understanding of why you like or dislike things, not just what you've clicked on in the past.
That's a powerful idea.
It is. And another direction I see is causal discovery for latent preferences.
Causal discovery for latent preferences. Wow.
So right now, the model relies on those features we have about users and items, right? Age, genre, price, whatever. But what if we could use the explanations themselves to uncover those hidden preferences, the things that aren't explicitly captured in the data?
Like digging deeper into the language people use, the reasons they give, to uncover those underlying motivations.
Exactly. Imagine analyzing all those user reviews, free-form feedback, even the explanations generated by the system, and using that text to figure out those causal relationships between concepts.
Like if people who love complex narratives in books also tend to enjoy character-driven stories in movies, even though those things aren't explicitly linked in the data.
Exactly. And the system could then use that knowledge to recommend things that match those hidden preferences.
It's understanding the connections between things, the things that make you, you, even if you can't articulate them yourself.
Right. And this paper, by showing how LLMs can generate and reason about explanations, it suggests that those textual explanations, they contain a lot of information about user preferences that we're not using right now.
It's like a treasure trove of data waiting to be mined.
Exactly. We could potentially use those causal discovery algorithms to learn these hidden preference structures directly from the text.
That would be a huge leap forward in personalization.
Absolutely.
Now, gotta be realistic, these are just ideas, right? A lot of research still needs to be done.
Of course. But this paper, Counterfactual Language Reasoning for Explainable Recommendation Systems, it's a fantastic starting point. It's paving the way for more transparent, trustworthy, and useful recommendation systems.
I'm excited to see where this research goes, and if you're interested in diving deeper, we highly recommend checking out the full paper.
The link will be in the show notes.
And it leaves us with a final thought.
Yeah. As AI gets more integrated into our lives, how will this ability to understand the why behind recommendations? How will that change our interactions with technology? And how will it change our understanding of ourselves?
Big questions, very thought-provoking. Thanks for joining us for this deep dive. We'll be back soon with more cutting-edge research.
See you then.